Hey, what's up everybody? I'd like to welcome you into another JUCE tutorial. And today what we're going to do is we're going to build a state variable filter using the JUCE DSP module. Now, JUCE came out with the DSP module a couple months ago, and in there are a couple different features. You have filter design capabilities, you have convolution, and you also have FFT as well. And so within the filter design, you have a couple different ways that you can design filters. So you could use the infinite impulse response IIR filter class. You also have a finite impulse response FIR filter design. Today what we're going to use is state variable filter SVT design. And the reason we're going to do that is because basically we could build one filter, and then we can have three different configurations in this one filter. So you could do a low pass, a band pass, and a high pass configuration off of this one filter, as opposed to the IIR and FIR filters, in which you would have to use different configurations depending on what state that you would want or what configuration you would want your filter to be in. So that's why we're going to do the SVT. So there are a couple things that we need to do in order to set up JUCE that we can use the DSP module. So the first thing is that if we go into modules, I've already done this, but what you want to do is you probably don't have the DSP module activated. So if you don't have the DSP module activated, what you have to do is you just have to hit this plus sign, add a module, global JUCE modules paths, and then you just have to click on DSP there to add that if you don't already have that. And then also, to use the DSP module, you also have to be using C++14. So if you go into your project settings, I believe it's in here. Pardon me. And then if you go down here to C++ language standard, this has to be set to C++14 in order for this to work. Okay, so I've already kind of built a skeleton project here, just so we weren't going through making value trees and making knobs and putting the knobs in the proper places and everything. And I'll just go ahead and I'll show you what I've done so far. So while that's building, I'll just go through some of the code. So what we have here is we have a combo box, we have a filter resonance, a filter cutoff dial, and a filter resonance dial, and then I've just given it some initial settings. These are basically kind of like what I did with the synth tutorial, these past couple tutorials, so very similar kind of thing. Only thing I've really added is I've set the pop-up display enabled, which means that when my mouse is over the dial, that it shows the actual value that the dial has. And then also I've done this down here at the bottom. I've done this function filter cutoff dial set skew factor from midpoint, and what that does is that basically gives us a logarithmic range. This is something I've discussed in the past, so I'm not going to go through it again, but basically I've set the midpoint to 1000 hertz. Okay, so other than that, it's all stuff that I've pretty much done in the synth in the synth tutorials, except I've just kind of taken the filter the filter class, and I've actually just kind of pulled it out. I've made it its own thing. So if we I'll just show you the UI really quick. And so you can see what's going on. So here we are. We have the cutoff. We have the resonance. Like I said, the low pass, band pass, or high pass. So it's all just kind of the same thing as what we had in this tutorial, except I don't have a filter actually implemented yet, and that's what we're going to do today. Okay. Pardon me. So first thing that we're going to do, so one thing that I should say is that the DSP class, if we go into the API, okay, or the DSP module, should I say, it's not really a class because it's more of a collection of different classes. Okay, so it can be a little bit tricky to find here in the if we go into the API classes, but what we can do is we can just type in state variable filter. And then you can see here that we have a couple different designs here that are from the DSP module. You have the DSP FIR, IIR. You have your own filter design if you want to make your own filter. And then we have this state variable filter, which is going to be the one that we're going to use. So I'm going to do that. I'm going to open a couple tabs so we don't have to just continually kind of go into the API and search here. Okay, so if I go to, so another thing that we're going to need, okay, is that we have this class here. It's called processor duplicator. So if you watched the last tutorial that I did, basically what I was saying, one of the most important things to know when you're creating your own audio effect or filter is that many times you have to do the processing individually on the left hand and the left hand side and the right hand side, or however many outputs that you have. But luckily what they've done is they've been nice enough to basically do this thing for the DSP module, where basically they've got a processor duplicator where you can input one of the mono processes from the DSP module, and then it'll basically duplicate it for you across both channels so that you don't have to do that iteration that we talked about the last tutorial. Okay, so we're going to go through that. Okay, and then we're also going to go through, there are a couple other ones here. So I think we got process, so we got process spec. So process spec basically is a way in our prepare to play function that we can basically relay the relevant settings that we need to our DSP objects. Okay, so we can relay the sample rate, the size of the buffer, and the number of the channels. Okay, and we'll do that. And then we also have, I'll go back through these as well as we're in the tutorial itself. So in here in the filter, we have this parameters to use. So basically the filter has two parts. Okay, so you have the filter itself, and then you have this part, the parameters, which is where we're actually changing the configuration of the filter itself, whether it's going to be a high pass, low pass, band pass. Okay, and there's a certain way that we need to be able to work with that, and so I'm just going to open this tab as well just so we have that there. Okay, and is there anything I'm missing? I think there's one more, which is context. Okay, so we need this function process context replacing. Okay, when we actually go to do our processing for our audio, so basically we're going to be taking the buffer, we're going to do some processing to it with the filter, and we need to input the buffer. And in order to do that, we need to do this with this object here called process context. Okay, and so we're going to do what's called process context replacing, which basically means that we're going to take the buffer, the audio in, and then we're going to do the processing, and then we're going to take that same buffer, and after we're done processing it, then we're basically going to put it out. Okay, so as opposed to a non-replacing context where we would be working with two different audio blocks, basically, which I don't really know about, but this is the one that we're using today, context replacing. And then I think we have one more. So you'll see that this is really nice. This is really nice what they've done, but there are just a couple different things that we need to do differently. So we got this audio block that we need. Okay, so we got this audio block class, and what this does is this basically is how we're going to show the DSP module or these objects which buffer that we're working with. So we basically got to say audio block is our buffer. Okay, and it doesn't replace the buffer. It's not like copying the buffer or anything. It's just saying it's just basically giving our buffer another name for us to be able to work with it with these DSP objects. Okay, so without further delay, we're going to go ahead and get started. So first thing that we need is our processor duplicator. Okay, so what we need is we need to use the DSP name here, and then we could go DSP processor duplicator. Okay, and then in here we need to put what type of mono processor. So here we would put our state variable filter. Okay, so this is going to get a little bit like kind of tricky with the syntax of it all, but just take it slow and hang with me, and you'll get it like I did. Okay, so for this one we're putting in our state variable filter. Okay, so we got state variable filter, and then we're using the filter itself, and then this is going to be a type float. Okay, so just to show you how I got that, it's just same thing as what's written right here. Okay, state variable filter sample type. Okay, so that's how that works. Now we have the state type. Okay, so if you don't know what state type is, that's the parameters that we're going to use. Okay, so we just basically need to do the same thing here. Is we just need to go DSP state variable filter parameters and float, and I believe, and then we just need to name it, so I'll just call this state variable filter. Okay, so I'm just going to build that real quick, just make sure that it compiles properly. Pardon me, sorry about all the coughing. I've had a really bad flu recently, but hopefully it's coming out of it. So cool, so build succeeded, so that's fine. Okay, so we're fine there, and then all this is all good. I'm just gonna turn the page on my notes here, make sure I don't miss anything. So now we need to go to the prepare to play. Okay, so I just have a global I have a global variable here called last sample rate. This is just so I can pass around my sample rate globally throughout this CPP file. Okay, so second thing that we need to do is we need to do this thing that I was talking about with the process spec. Okay, so what this does is that it basically allows us to pass on information about the plugin itself, okay, into these DSP module objects. Okay, so what we could do is we could say DSP process spec, and I'll just call it spec. Okay, just making sure I have it right. And then what I could say is spec dot, sorry, I'm hoping I'm not making you guys dizzy with this. So we got spec dot sample rate equals our last sample rate. Okay, spec dot maximum block size equals samples per block, and then spec dot num channels equals get, I'm trying to remember what this is called, get base, I'm just going to try get num, get main bus num output channels. Okay, that's what I'm going to put there. Okay, so that should be fine. Don't know why it's giving me an error, but let's just see what it's saying. Okay, it's all good. So that's fine. So now what I can do is I can go to my state variable filter now, and then I can actually, this could be a little bit confusing. So you have the state variable filter, right? And then that's living, and then that's inside the process duplicator. So what we really need are the process duplicator functions. Okay, so when we need to access the parameters of the filter, there's a bit of a syntaxy kind of way to do that, but I'll show you how to do that. Okay, so in here we have this function where we're just basically initializing the effect. Okay, and so this is just prepare, and then we just put spec. Okay, so it's state variable filter, prepare, and then spec. Okay, so that's fine. I'm also gonna reset on prepare to play as well. So basically, we don't have any sort of garbage if we've been doing something to the audio and then we stop playing. Basically, this will clear out any garbage values that we have. So we'll have state variable filter reset. Okay, and that I just got from here. Okay, so just this reset just resets, gets rid of all the garbage values. Pardon me. So now what we need to do is, so we need a way that we can update the parameters. So basically we have this combo box, we have the filter cutoff, we have the filter resonance, and then what we need to do is we need a way where when all of these things are changing, that we're basically updating the state of the filter, or updating the parameters of the filter. Okay, so I'm going to do this using a function. Okay, I'm just going to call this void update filter, and then I'll just put that here. So void svt plugin save me autocomplete. Okay, update filter. Okay, and then in here we're just going to basically say, you know, if it's the first menu on the combo box, which is low pass filter, then make it a low pass filter, update the parameters, update the filter cutoff, so on and so forth. Okay, so what we can do is we just have to look at our items from the value tree that we have here. So we have cutoff, we have resonance, and we have filter menu. So what we're going to do is we're just going to dereference those down here. I'm just going to store them in different, in just some local variables here, just so they're easy to pass around rather than having to keep on saying tree dot get raw parameter value. So I'm just going to say int menu choice. So this is going to be from our menu, which chooses what type of filter that we have. So this is going to be equal to, I'm going to be using the star operator here to dereference what's going to be a pointer. So it's going to be tree get raw parameter value, and then this is menu item, I believe it's called filter menu. Okay, so this is just the value that's coming in from the combo box menu that's choosing what type of filter that we're going to be using. So going back to, I really shouldn't go back and forth up and down like that. So that's cool. I'm going to do int cutoff equals tree get raw parameter value, and then I believe I just called that cutoff. Just going to check that. Yeah, so it's called cutoff. Okay, and then we're going to do the same thing for resonance. So int, I'm just going to call this res equals tree get raw parameter value, and then This was called resonance. Okay. So now what we have to do is we just have to tell it what we want it to do if the user selects the first item on the menu. So if, oh no, is my thing gonna crash? Okay, cool. If menu choice is equal to 1, I think I have that right. I'm just thinking here. Just thinking that it needs to be 0 because it's going to be starting from 0 basically. So if menu choice equals 0, then what we need to do is we need to set the filter to a low pass. Okay, so the way that we're going to do that is we're going to go state variable filter. Okay, now what I'm going to do is I'm going to go back to the API because I want to show you. So remember, we're in process duplicator, okay? And then what we have is we have this attribute called state, okay? This is what allows us to basically set or reset any of the parameters that we have, okay? So if I go back here for a second, right? And then I go back into my declaration, you'll see that I made two arguments here. So I have the filter itself, and then I have the actual parameters of the filter. Okay, so what I'm doing now is I'm actually accessing this part right here, the parameters themselves. Okay, actually it's right here, the parameters themselves, because that's what I want to change. I want to change the parameters. Okay, and then if we go into the parameters class here, I'll show you what I mean. So here is where we could do low pass, band pass, and high pass, okay? Then we can also set the filter cutoff frequency. So basically we gotta, that's why we're going into this parameters class here. So what we need to do here is we need to say state variable filter, and as I said before, has to, let me go back here again, has to say state, okay? So it's state variable filter dot state, okay? Now the parameters is a pointer, okay? So what I need to do is I need to use the arrow. I need to use the arrow operator here, okay? And so I'm saying I'm going into the parameters, and now I'm going to tell it what configuration that I want it to be. Okay, so I'm going to say DSP filter design float. Oh, nope. Sorry about this. This state variable filter. Okay, and then it's going to be the parameters. Okay, so not the filter, the parameters themselves. And remember, we made that of type float. Okay, and then what I'm doing is I'm going into, excuse my dog. We're going into type, okay, because we're defining what type that we want this to be. So we're doing type. Come on, catch up. Should unfreeze here in a second, hopefully. No, is it gonna die? Come on. Dang thing. Okay, I'm just gonna, sorry about this, guys. Just going to force quit out of that, and then I'm just gonna reload from here again. Sorry about this. Hope you can forgive me for not wanting to do the whole tutorial over again. Okay, so let's go back in again. Okay, so here we have type, and then low pass. Okay, do I need to do, no. Okay, so what have I done here? No. Oh, this is type. Sorry about this. type, not parameters. So just to review what I'm doing, because that can be a little bit confusing. So we're in our process duplicator here, and I needed to go into the parameters and reset the parameters. Okay, so what I've done is I've basically gone into the state part of the of this process duplicator, and I'm basically resetting that to this, and I'm saying, okay, I want this to be a low pass filter now. Okay, so I hope that's clear. If it's not clear, then drop me a line. So now what we need to do is we want to basically set the parameters, the cutoff frequency and the resonance and all of that. Okay, so we have state variable filter, state, and then let's think about this here. So what I need to do is I need to get to set cutoff frequency. Okay, so let's think about this for a second. So I think I can just say set cutoff frequency. I'm going to try this and see if this works. Pardon me. So we got double sample rate, we got the frequency, and then we got the resonance. Okay. So we got last sample rate, which is what I named the global variable where I'm holding the sample rate. Then frequency, we can just get from here, from our value tree, which is cutoff, and then res, which is our resonance. So this is going to tell me it needs to be an arrow. Yeah, so because it's a pointer. Okay, so that seems fine. So let's just do this for the other two. Okay, so I'm just basically gonna do this, copy and paste this here. I'm sure there must be a more efficient way of doing this. Maybe not. So I'm just changing this low pass to band pass for the second one. Okay, and then I'm just gonna copy and paste this. I'm gonna make this a 2, which is the second item on our list, which is going to be a high pass filter. So just make this high pass filter, and then once again we just get our parameters and we just relay those. Okay, so now that we've written that function out, what I'm going to do is I'm just going to put that here, just so we can get the filter parameters that we need to be at when we're getting ready to play the audio again. Okay, so I think that's all good. I'm just going to do a quick build here, just make sure that it builds properly. So I think that's fine. I'm just going to make some space for this while I'm waiting for this to build. And then I'm going to go over here, and I'm just going to exit out of a couple. No, I'm going to leave them up. So now we need the audio block. Okay, so this is our DSP audio block. So build succeeded there. That's all good. I'm just going to go ahead and stop that. So now we're in our process block. Okay, so now, as I said before, basically we're going to use this audio block class. And what this is going to do is basically we're going to say that audio block just basically means our buffer. Okay, so I could just say DSP audio block, and it's of type float. I'm just going to call this block, and then I'm just going to say that is equal to our buffer. So our buffer from our process block, that's what we're talking about. Okay, so that's fine. Now what we need to do, so we don't need to, so one of the big things about this DSP class that's really awesome is that we don't need to iterate through the for loops, go through the channels, go through the samples, so on and so forth. We actually could just say process this block and it actually works. Okay, so I think if I say state variable filter process, oh, what it do? Just acted weird on me. Process. This is the one that I want. Okay, so now we need that context, that context that we were talking about. So if we go over here, we have this DSP process context replacing context sample type. And then, so basically we got to say DSP context, what's it called? Process context replacing, and then that's a type float, and then here I should say block, because that's just where we put our audio block. Okay. Only other thing that I'm missing here is that I need to update the parameters again, or update filter rather. So did I say update filter? Yeah, so I did that. So I think this should be fine. Okay, so I'm going to go ahead and build this, and fingers crossed we should be all right. Okay, so I know that's a little bit syntaxy, but I hope you got where I was coming from. I've also cleaned this out. This was very helpful. So I cleaned out like all my plugins, and I've just got the ones that I need loading in the host. So now I can just use this guy's audio player. This always takes a bit to load, and hopefully everything works fine. So just waiting for a second. By the way, be sure to join our Discord group and everything. I'm going to just shout that out really quick. Big shout out to everybody that's been talking in there. Great. Okay, that's all good. Okay, and just do this. And now I'm just going to put an audio file in here. Sounds like it's working. So here's our filter. So the filter works fine. So let's just try the resonance now. Okay, now I'm going to do bandpass filter. And then I'm going to do a high pass filter. Awesome. Pardon me. So as you can see, it works really well. You can see that as I was moving the filter quite quickly up and down, that it wasn't crashing as was the problem that I was having with the other filter that I was using in the synth tutorial. So I was actually going to do this within the synth tutorial, but I thought, it's just a little bit too crazy because the code base is getting a little bit bigger. But I hope that's helpful for you. And we'll probably do some filter design and go through the IIR and FIR filter as well, and go through that and mess around with that. So I hope you found this helpful. If you have any questions or anything, or if you have any problems, you can just drop a comment below or come over to the Discord group. And if nothing else, I'll see you next time.